Z is a complex number of unit modulus and argument theta. Then argument of 1 plus z by 1 plus z bar is equal to minus theta pi by 2 theta pi minus theta. Z is unit modulus. Z is of unit modulus and is argument theta. So polar representation of Z will be Z equal to, we can write cos theta plus phi sin theta. Okay, so 1 plus z by 1 plus z bar will be 1 plus cos theta plus phi sin theta by 1 plus cos theta minus phi sin theta. Since z is cos theta plus I sin theta, so z bar will be cos theta minus I sin theta, conjugate of z. Now we can write 1 plus cos theta as 2 cos square theta by 2 and sin theta as 2 into sin theta by 2 into cos theta by 2. Okay. Similarly, 1 plus cos theta is 2 cos square theta by 2 minus I sin theta means 2 sin theta by 2 cos theta by 2. Okay. Then we can take common 2 cos theta by 2 from numerator and denominator. Then we get cos theta by 2 plus I sin theta by 2 by cos theta by 2 minus I sin theta by 2. Okay. Now cos theta plus I sin theta by 2, cos theta by 2 plus I sin theta by 2 means e to the power I theta by 2. And cos theta by 2 minus I sin theta by 2 means e to the power minus I theta by 2. It means e to the power I theta. So argument of 1 plus z by 1 plus z bar must be theta. Okay, so option C is correct. Next problem. Here x plus 1 by x equal to root 3. We have to find the value of x to the power 18 plus x to the power 12 plus x to the power 6 plus 1. If we take x equal to cos theta plus I sin theta, then 1 by x will be cos theta minus I sin theta. Then x plus 1 by x must be 2 cos theta. Now we can write x plus 1 by x. Here x plus 1 by x root 3. We can write it as 2 into root 3 by 2. This means 2 cos I by 6. 2 cos pi by 6. So x is cos pi by 6 plus I sin pi by 6. Okay. Then x to the power 6 will be cos pi plus I sin pi. it means -1. So x to the power 12 must be 1 and x to the power 18 will be -1. So the value of x to the power 18 plus x to the power 12 plus x to the power 6 plus 1 is -1 plus 1 minus 1 plus 1. This is 0. So option A is correct. Okay, next one. Here z is e to the power I theta. Then the value of z square minus 1 by z square plus 1. So we can write z square minus 1 by z square plus 1 as cos 2 theta plus I sin 2 theta. Since here is z is e to the power I theta plus 1 by cos 2 theta plus I sin 2 theta plus 1. Sorry, here minus 1. Now 1 minus cos 2 theta is 2 sin square theta. So we can write it as minus 2 sin square theta. Cos 2 theta minus 1, it will be minus 2 sin square theta plus I sin 2 theta. It will be 2 sin theta cos theta. Here cos 2 theta plus 1. So 2 cos square theta plus I 2 sin theta cos theta. Then we can take common sin theta from numerator and cos theta from denominator. Then we get sin theta by cos theta into minus sin theta plus I cos theta by cos theta plus I sin theta. Then we can take common I from numerator. Then we get I sin theta, and it will be cos theta minus 1 by I. Minus 1 by I means I sin theta by cos theta plus I sin theta. So we get I tan theta. Okay, so answer is option A, I tan theta. Next problem. We have to find the value of cos theta plus I sin theta by I cos theta plus sin theta to the power 4. Cos theta plus I sin theta by I cos theta plus sin theta. It means cos theta plus I sin theta by, we can take common I from denominator. Then we get I cos theta minus I sin theta. Okay, it means 1 by I e to the power I theta by e to the power minus I theta. So we get 1 by I e to the power I2 theta Okay, now cos theta plus I sin theta by I cos theta plus sin theta whole to the power 4 is 1 by I e to the power I to theta whole to the power 4. I to the power 4 means 1, so we get e to the power I 8 theta, and it is cos 8 theta plus I sin 8 theta. So here option C is correct, cos 8 theta plus I sin 8 theta. Next problem. Alpha and beta are different complex numbers with mod beta equal to 1. Then mod of beta minus alpha by 1 minus alpha by beta will be 0, half, 1, 2. First, we evaluate the value of beta minus alpha by 1 minus alpha bar beta mod square. Okay, it will be, we know mod z square is z into z bar. Okay, using this we get beta minus alpha into beta minus alpha bar by 1 minus alpha bar beta into 1 minus alpha bar beta whole bar. We can break it as beta bar minus alpha bar, since z1 plus z2 whole bar is z1 bar plus z2 bar. Okay, by 1 minus alpha bar beta into 1 minus alpha beta bar, since z bar whole bar is z. Okay, then we can break it as beta into beta bar, it means beta bar square, minus beta into alpha bar minus alpha beta bar plus alpha into alpha bar, it means mod alpha square, by 1 minus alpha beta bar minus alpha bar beta plus alpha bar into alpha mod alpha square, beta into beta bar mod beta square, equal to, here mod beta is 1, so this is 1 minus beta alpha beta bar plus mod alpha square by 1 minus alpha beta bar minus alpha bar beta plus mod alpha square. So we get numerator and denominator the same. So this is 1. So answer will be 1. Next problem. The locus represented by mod of z minus 1 equal to mod of z plus I is a circle of radius 1, an ellipse with Pocket 1 0 and 0 minus 1, a straight line through the origin, a circle on the line joining 1 0 and 0 1 as diameter. Now there is a formula. If mod of z minus z1 by z minus z2 is 1, then z must represent a straight line. Okay, so here mod of z minus 1 by z plus I equal to 1, so z must lie on a straight line, so only option straight line is C, so C is correct, and z must be passed through origin, since it satisfies. If we put z equal to 0, then it will be 1. Okay, so it's satisfied. So option C is correct. Next problem. If the area of the triangle formed by the points z, z plus iz, iz is 50, then mod z is 1, 5, 10, 100. Now the area formed by z, z plus iz, and iz is half mod square. Half mod z square. Now given condition is this is equal to 50. So mod z square equal to 100. Mod z is 10. So option C is correct. Okay, next problem. We have to find the value of 1 plus sine theta plus I cos theta by 1 plus sine theta minus I cos theta whole to the power n. Look at how we can write as 1 plus sine theta plus I cos theta. 1 plus sine theta minus I cos theta. 1 plus sine theta, it means we can write as sine theta by 2 plus cos theta by 2 whole square. Observe that if we break this, we get this is equal to 1 plus sine theta. Okay, and cos theta means cos square theta by 2 minus sine square theta by 2. Similarly, 1 plus sine theta, it means sine theta by 2 plus cos theta by 2 square minus I cos square theta by 2 minus sine square theta by 2. Okay, then we can take common sine theta by 2 plus cos theta by 2 from numerator denominator. We get sine theta by 2 plus cos theta by 2 plus I cos theta by 2 minus sine theta by 2 by sine theta by 2 plus cos theta by 2 minus I cos theta by 2 minus sine theta by 2. Now we divide numerator and denominator by 1 by root 2. So we get sine theta by 2 plus cos theta by 2 plus I cos theta by 2 sine theta by 2 1 by root 2 sine theta by 2 plus cos theta by 2 minus I 1 by root 2 cos theta by 2 minus sine theta by 2. Okay, now 1 by root 2 sine theta by 2 plus cos theta by 2, we can write it as cos pi by 4 minus theta by 2. Okay, and 1 by root 2 cos theta by 2 minus sine by theta by 2, we can write it as plus I sine pi by 4 minus theta by 2. Okay, similarly we can write here as cos pi by 4, this will be pi by 4 minus theta by 2. I sine pi by 4 minus theta by 2. So we get e to the power I pi by 4 minus theta by 2 by e to the power minus I pi by 4 minus theta by 2. So we get e to the power I pi by 2 minus theta. Okay, so this will be e to the power I pi by 2 minus theta where n means e to the power I n pi by 2 minus n theta. So option A will be true. Okay, next problem. Z1 Z2 are two complex numbers such that mod Z1 equal to mod Z2 plus mod of 0 minus 01. Then imaginary of Z1 by Z2 is 0. Real part of Z1 by Z2 is 0. Real part of Z1 by Z2 equal to imaginary part of Z1 Z2. None of this. Now we can take Z1 as R1 e to the power I theta 1 and Z2 as R2 e to the power I theta 2. If we put there, then we get R1 equal to R2 plus R1 e to the power I theta 1 minus R1 e to the power I theta 2. Okay, then R1 minus R2 equal to mod of R1 cos theta 1 plus R1 I sin theta 1 minus R2 cos theta 2 minus I R2 sin theta 2. Okay, now squaring both sides we get R1 square plus R2 square minus 2 R1 R2 equal to the real part will be R1 cos theta 1 minus R2 cos theta 2. So R1 cos theta 1 minus R2 cos theta 2 square plus an imaginary part will be R1 sin theta 1 minus R2 sin theta 2 plus R1 sin theta 1 minus R2 sin theta 2 square. R1 square R2 square minus 2 R1 R2 equal to, look at here we get R1 square cos square theta 1 and here R1 square sin square theta 1. By adding this we get R1 square. Similarly here we get R2 square cos square theta 2 and here R2 square sin square theta 2. Adding this we get R2 square. And these two terms will be left minus 2 R1 R2 cos theta 1 cos theta 2 minus 2 R1 R2 sin theta 1 sin theta 2. So we have minus 2 r1 r2 equal to minus 2 r1 r2. If we take common minus 2 r1 r2, then we get cos theta 1 cos theta 2 plus sin theta 1 sin theta 2. So we can write it as cos theta 1 minus theta 2. Okay, then we get cos theta 1 minus theta 2 is 1, since r1 r2 not equal to 0. Okay, now z1 by z2 is r1 by r2 into e to the power I theta 1 minus theta 2. It means r1 r2 cos theta 1 minus theta 2 plus I sin theta 1 minus theta 2. If cos theta 1 minus theta 2 is 1, then sin theta 1 minus theta 2 will be 0. So imaginary part of z1 by z2 must be 0. So option is correct. Okay. Next problem. Here z1 and z2 two complex numbers such that z1 bar plus I z2 bar equal to 0, and argument of z1 and z2 is 5. Then we have to find argument of z1. Now z1 bar plus I z2 bar equal to 0. So z1 bar equal to minus of I z2 bar. If we take both sides its conjugate, then we get z1 equal to minus of I z2 whole bar. This means minus of I bar. It means I and z2. Since z bar whole bar equal to z. Okay. Now argument of z1 z2 is 5. So argument of z1 is z1 means I z2. So we can put it I z2 z2 to 5. Now argument of I z2 square, it will be argument of I pi by 2 plus argument of z2. So it will be 2 theta equal to pi. Suppose argument of z2 is theta. Okay, then 2 theta is pi by 2 and theta will be pi by 4. So argument of z2 is pi by 4. Then argument of z1 will be pi minus pi by 4. That means 3 pi by 4. How we get this? Since argument of z1 into z2 is pi, so argument of z1 must be pi minus argument of z2. This means pi by 4. So 3 pi by 4. So option C will be correct. Next problem. Z is a complex number satisfying mod of z minus pi I. Z is a complex number satisfying mod of z minus 5i by z plus 5i equal to 1. Then z lies on a line x equal to minus 5, line y equal to 6, x-axis, y-axis. Now we can write z minus 5i by z plus 5i mod square is 1. Then we use mod z square means z into z bar. Okay, use it. We get z minus 5i into z minus 5i whole bar by z plus 5i by z plus 5i whole bar equal to 1. This means z minus 5i into z bar plus 5i, since I bar means minus I, by z plus 5i, since I bar is minus I. So we get z into z bar mod z square plus 5iz minus 5iz bar plus 25 equal to mod z square minus 5zi plus 5iz bar plus 25. Then we get 10iz equal to 10iz bar. Hence we get z equal to z bar. That means y must be 0. Imaginary part of z must be 0. So z lies on x-axis. Okay, so option C is correct. Next problem. Here z is a complex number such that amplitude of z minus I by z plus I is pi by 4. Then z lies on a straight line, circle, ellipse, none of these. We can take z as x plus iy. Then amplitude of z minus I by z plus I is amplitude of x plus iy minus I by x plus iy plus I. It means amplitude of x plus iy minus I minus amplitude of x plus iy plus I. Since amplitude of z1 by z2 equal to amplitude of z1 minus amplitude of z2. Now amplitude of x plus iy minus I means tan inverse. Tan inverse imaginary part is y minus 1 and real part is x minus tan inverse imaginary part is y plus 1 and real part is x. Now tan inverse A minus tan inverse B is tan inverse A minus B by 1 plus AB. So we get tan inverse y minus 1 by x minus y plus 1 by x by 1 plus y square minus 1 by x square. This will be tan inverse minus 2 by x by x square plus y square minus 1 by x square. Tan inverse minus 2x by x square plus y square minus 1. Now the given condition is amplitude of z minus I by z plus 1 is pi by 4. So this is pi by 4. Then we get minus 2x by x square plus y square minus 1 is 10 pi by 4 means 1. So equation will be x square plus y square plus 2x equal to 1. So this is a circle. This is a circle. So option B will be correct. Next problem. We take if we take z1 is r1 cos theta 1 plus I sin theta 1 and z2 is r2 cos theta 2 plus I sin theta 2. Then putting this in the given condition, we have r1 cos theta 1 plus r sin theta 1 is theta 1 plus r2 cos theta 2 plus I sin theta 2 equal to mod z1 means r1 plus mod z2 means r2. And we squaring both sides, then we have this square. Now it means real part means r1 cos theta 1 plus r2 cos theta 2. So r1 cos theta 1 plus r2 cos theta 2 square plus imaginary part is r1 sin theta 1 plus r2 sin theta 2. So r1 sin theta 1 plus r2 sin theta 2. This is square equal to r1 square plus r2 square plus 2 r1 r2. Okay. Now here we get r1 square cos square theta 1 and here r1 square sin square theta 1. By adding this we will get r1 square. Similarly here we have r2 square cos square theta 2, and here r2 square sin square theta 2. Adding this, we will get r2 square plus 2 r1 r2 cos theta 1 cos theta 2 plus 2 r1 r2 sin theta 1 sin theta 2 equal to r1 square plus r2 square plus 2 r1 r2. Then taking common r1 r2, we have r1 r2 into cos theta 1 minus theta 2, theta 1 minus theta 2. This is 2 r1 r2. Okay, so we have cos theta 1 minus theta 2 is 1. Cos theta 1 minus theta 2 is 1. Now option are argument of z1 equal to argument of z2, and argument z1 plus argument z2 is 0, and argument of z1 into argument z2 is 0. Since cos of theta 1 minus theta 2 is 1, it means cos 0. Cos 0. So theta 1 minus theta 2 is 0. From theta 1 equal to theta 2. So argument of z1 equal to argument of z2. So option is correct. In this problem, we can also say, since cos theta 1 minus theta 2 is 1, so sin theta 1 minus theta 2 is 0. Okay. Then imaginary part of z1 minus z2 must be 0. We can also say. Okay. Next problem. We have to find the minimum value of mod of z1 plus mod of z1 minus 1. Now we can write 1 as z minus 1. There is a formula z1 minus z2 greater than mod of z1 plus mod of z2. There is a formula z1 minus z2 less than equal to mod of z1 plus mod of z2. So we can apply it. z minus 1 less equal to mod of z1 plus mod of z minus 1. Now this is 1. So mod of z plus mod of z minus 1. So minimum value of mod of z plus z mod of z minus 1 is 1. So option C is correct. Next column. Argument of z is negative. Then argument of minus z, minus of argument z is pi minus pi minus pi by 2 pi by 2. Okay. Look at argument of z negative. So we can take z as minus x minus iy, where x, y positive. Okay. Then minus z will be x plus iy. If we represent it in complex plane, then we get z must be here, since z is minus x minus iy, and this is z, and minus z is x plus iy, so minus x will be there, minus z, so this is minus z, this is z. Now argument of minus z, argument of minus z is this is suppose theta 1, and argument of z will be this, suppose this is minus theta 2, since this is negative, so argument of minus z minus argument of z, this means theta 1 minus of minus theta 2, so is theta 2. Now theta 1 plus theta 2 is equal to pi, this is pi, okay, this is pi, so option is correct. Okay, next problem. The value of summation of sine 2k pi by 11 plus I cos 2k pi by 11 k equal to 1 to 10 is minus 1 I minus I and 1. Just consider the equation x to the power 11 equal to 1. So its roots will be x equal to cos 2k pi by 11 plus I sin 2k pi by 11, where k equal to 0, 1, 2, 10. This is De Moivre's theorem. We just use De Moivre's theorem. 11th root of unity. Okay. Now, if we add this root, then we get cos 2k pi by 11 plus I sin 2k pi by 11, k equal to 0 to 10. If we add this, we get 0. If we add all the root, we get 0. How? Now we can break it as x minus 1 into 1 plus x squared plus x to the power 10 equal to 0. Then plus x plus x squared plus dot plus x to the power 10 must be 0. So all the root of this equation, if we add this, we get 0. Now for k equal to 0, this will be cos 0 plus I sin 0. So this is 1 plus, we can write 2k pi by 11 plus I sin 2k pi by 11 from k equal to 1 to 10. Okay. Then if we compare the real part and imaginary part in both sides, then we get 1 plus summation of cos of 2k pi by 11 k1 to 10, this will be 0, and imaginary part means sin 2k pi by 11 k equal to 1 to 10, this will be 0. Now the summation k1 to 10 cos 2k pi by 11, this will be minus 1. Now look at the question is summation of sin 2k by 11 plus I cos 2k pi by 11 k equal to 1 to 10. So this must be, this is 0. Summation of sin 2k pi by 11 k equal to 1 to 10 plus I summation of cos 2k pi by 11 k equal to 1 to 10. This is 0. This is 0. 0 plus I into the summation of cos 2k by 11 k equal to 1 to 10. This is minus 1. So I into minus 1. So this is minus I. So value of this will be minus I. So option B is correct. Next problem. The product of all value of 1 plus I root 3 whole to the power 3 by 4 is 8i minus 8i, 8 minus 8. Look at the polar represent of 1 plus I root 3 will be, that means 2 into cos pi by 3 plus I sin pi by 3. Okay, so we can write 1 plus I root 3 is 2 into cos pi by 3 plus I sin pi by 3. Then 1 plus I root 3 whole to the power 3 is 2 cube plus cos pi plus I sin pi. Okay, so we get leave it. Leave it. Then 1 plus I root 3 to the power 3 by 4 will be 2 to the power 3 by 4 into cos pi plus I sin pi to the power 1 by 4. Again we use a De Moivre's theorem. Then we get 2 to the power 3 by 4 into cos 2k pi plus pi by 4 plus I sin 2k pi plus pi by 4. Okay, where k equal to 0, 1, 2, 3. Since this is 1 by 4. Then we can break it as 2 to the power 3 by 4 into cos pi by 4 plus I sin pi by 4 into cos 2k pi by 4 plus I sin 2k pi by 4. Okay. From there we can write to the power 3 by 4 into cos pi by 4 plus I sin pi by 4 into cos 2 pi by 4 means pi by 2 plus I sine 2 pi by 4 means pi by 2 whole to the power k. We can write it. Okay. Number of root of 1 plus I root 3 whole to the power 3 by 4 is 4 for k equal to 0, 1, 2, 3. So if we multiply the root, then we get 4 times 2 to the power 3 by 4. So it means 4 to the power 4. And 4 times cos pi by 4 plus I sine pi by 4. Okay. And cos pi by 4 plus I cos pi by 2 plus I sine pi by 2. It means cos pi by 2 0, I sine pi by 2, sine pi by 2 1. So I to the power k. So I to the power 0 plus 1 plus 2 plus 3. It's equal to 2a cube, and this is cos pi plus I sine pi, and I to the power is 6. So it will be 8, and cos pi plus I sine pi, this is minus 1, and I to the power 6, that will be minus 1. Okay, so we get 8. So the product of all values of 1 plus I root 3 whole to the power 3 by 4 is 8. So answer C is correct. Next problem. Z is a complex number 4 by 1 minus I. We have to find Z bar, a conjugate of Z. And Z equal to 4 by 1 minus I. So Z bar will be 4 by 1 minus I whole bar. So this is 4 by 1 minus I whole bar. So this will be 1 plus I. Okay, since Z1 by Z2 whole bar, it means Z1 by Z2 bar. Okay, and here 1 bar, Z1 plus Z2 whole bar is Z1 bar plus Z2 bar. So here 1 minus R whole bar, it means 1 bar equal to 1. And I bar means minus 1 I. So we get 1 plus I. So 4 by 1 plus I. So answer option D is correct. Please like, share and subscribe. Thank you.